find the root of a given equation whose one root is given, which is a complex root, we know that another root is the conjugate of the complex root. So, and we know that x minus the root is a factor of the equation. So by solving both the factors, we get an equation which is also a factor of the given equation. So by dividing the given equation by the factor, we get another equation, and by solving that equation, we get all the roots. To find the root of a given equation which has four distinct roots of equal moduli, we let case 1 where two roots have imaginary part equal to 0 and two roots have imaginary part not equal to 0. Since we know the factor is x minus the roots, so by putting all the roots, equating it to 0, we get an equation which doesn't have the term x square. So this case is not possible. So considering case 2 where we'll let all the four roots which have the imaginary part not equal to 0, the factor is x minus the roots, and so putting all the roots, equating it to 0, we get an equation, and this equation has x4 term which has the coefficient 1, but the given value equation has x4 terms coefficient as 3. So to equate this, we'll multiply 3 to the whole equation. So after that, we'll compare this equation with the given equation which gives us the value of r, and by comparing x, we get cos theta plus cos theta 1, and by comparing x square, we get cos theta into cos theta 1. From here we can take out cos theta value. So putting cos theta value in the previous term, which was termed as equation 2, we get the value cos theta and cos theta 1. From here we can get the term values of sin theta 1 and sin theta. From here we can take out all the roots. To prove that all roots of the equation are real, we have the equation and we need to equate the right side of the value to 1. So multiplying x plus b to the whole equation, we get this equation. Now we'll multiply minus to both sides, then we'll plus minus 1 n times. So we get this equation. Now we'll put a plus ic and a minus ic in this equation, as a plus ic and a minus ic are the roots of the equation. So putting the values a plus ic here, we get this equation, and putting which will put as equation 1, and putting the value a minus ic, we get this equation which will term as equation 2. So subtracting equation 1 from equation 2, we get this equation where the value in the bracketed part is real, since it is given that a, a1, a2 and all the a terms are real and b is real. So it is only possible for ic this part to be 0, for this equation to be 0. So the bracketed part is real, so all the roots are real. In Descartes' rule of sign, we let an equation as f of x, where we write all the signs and the number of variation is the number of positive root for f of x, and for f of minus x, we let the number of variation of sign in the negative root as the number of negative roots. To find the root of a given equation by using Cartan method, we need to let x equal to b plus u. Then by cubing both sides, x cube equal to v plus u whole cube. Now solving this, we get this equation. Now comparing this equation with the given equation, when we compare the x, we get u equal to 9 by v. When comparing the constant, we get minus u cube plus v cube equal to minus 54. Now u cube plus v cube equal to 54, where the value of u is 9 by 4. So substituting the value of u by 9 by v, we get 9 cube by v cube plus v cube equal to 54. Now letting v cube equal to y. 9 cube by y plus y minus 54. Now to make this a suitable equation, we multiply this equation by y. So we get y square minus 54y plus 729. Now solving this, we get y equal to 27. Since we let v cube equal to y, so y equal to v cube equal to 27. So v equal to 3. And we know that if 3 is one root, then 3 by 2 minus 1 plus I root 3 and 3 by 2 minus 1 minus I root 3 are the other roots. So from 1, we know u equal to 9 by v. So if v equal to 3, then u will be u equal to 9 by v equal to 3. And when v equal to 3 by 2 minus 1 plus I root 3, u will be 9 by 3 by 2 minus 1 plus I root 3 whole, which is 3 by 2 minus 1 minus I root 3. Again, accordingly, when v is 3 by 2 into minus 1 minus I root 3, u will be 3 by 2 minus 1 plus I root 3. So as we let x equal to u plus v, here u plus v will, all the u and v plus will get the answers as 6, -3 and -3. Now we have all the roots. To find the roots of a given equation, given that the product of the two roots is 1, we let the roots be alpha 1, alpha 2 and alpha 3 and write a0, a1, a2 and a3 values from the equation. According to the question, alpha 1 and alpha 2 product is 1. We let this, and by the relation between roots and coefficient, we have this equation, and putting the values accordingly, we get equation 2. Then again, by this relation of roots and coefficient and putting the values accordingly, we get the equation 3. And by putting the values of this another relation, putting the values accordingly, we get alpha 3. So, and we label it as 4. So putting the value of alpha 3 in equation 2, we get this equation, and then putting this alpha 1 value in alpha 1 and alpha 2 equation 1, we get the value of alpha 2. We get the value of alpha 2. So again, by putting the value of alpha 2 in this equation, we get alpha 1, and then we have all order. To make a matrix in an echelon form, we need to check the first element. If it is a non-zero term, then it is a pivot element. Then we need to make the elements below it zeros, and after turning it, we need to check the second element in the second row and column. If it is a non-zero term, then it will be a pivot element, and we'll make the elements below it 0. If it is a zero term, then we need to check the elements below. If any element below is a non-zero, we'll exchange that row with the second row. But if it is, all the values are 0, then it is not possible. So we need to check the next line, next column, and if the next third row and column element is 0, then we need to check the element below it. Since here we have a non-zero element here, so we'll exchange this row with the previous row, and we have a pivot element here. Then accordingly we will check the next row and column, and since here it is a zero term and below it the element is also 0, so we'll go to the next element in the same row. And here we have a non-zero element, so it is a pivot element. Here we have the echelon form, and from there we can determine the rank. Now, to make it a reduced echelon form, we need to make the elements above the pivot elements zeros. So by making the elements above the pivot elements 0, here we have the reduced echelon form. To determine the general solution of a homogeneous system, we need to write the coefficient matrix first, then we need to make it in an echelon form. After writing it in an echelon form, we need to write in an Ex equal to 0 form. After writing it, we need to multiply it in a matrix product form, and we need to do it from the last column, last row, and by doing it, we can determine the values of x, x cube, x4, and as by we get the values of x3 here, and then here x1. We'll write these values directly, and where we don't have the values, we'll just place it as it is. Here x square, x2 doesn't have a value from here, so we'll write it as just x2, so it has a coefficient 1. So after that, we need to write the coefficients of x2's here and plus all the terms x4's here. Then we need to make it a product of x2 and all the coefficients and plus x4 and all the coefficients. Now, or by putting any value in x2 and x4, we'll get all these values which will satisfy the equations. To find the roots of a given equation by using Euler method. To find the root of a reciprocal equation, we need to check the degree and type of the equation. If it is in a even degree and first type, then it is in a standard form. Here it is not in a standard form, so we will take the terms with the same coefficient and take the common out. Then we'll expand the x's and in such a way that we have x plus 1 common term in all the terms. Then we'll take x plus 1 common. Then we'll get x plus 1 into an equation, and the equation will be in a standard form. Now, to solve a standard form equation, we'll take the terms with the same coefficient together, and then we'll take the coefficient out common. Then we'll be left with a term which has here x square. So we'll divide the entire equation by x square. Then we'll have this equation. Now we'll let x plus 1 by x equal to t, and by doing x t square, we'll get t square minus 2 equal to x square plus 1 by x square. Now putting these values of t and t square minus 2 in the equation 1, we'll get the values of t, and putting the value of t as x plus 1 by x, we'll get the values of all the x's. So now we have all the roots. Let x equal to root p plus root q plus root r. Now squaring both sides, we get x square equal to p plus q plus r plus 2 root pq plus qr plus rp. Now, taking p plus q plus r on the left hand side and squaring both the sides, we get this equation. Now, comparing this equation with the given equation, the x square term, we get p plus q plus r, and the x term, from the x term, we get p plus q plus r, and from the constant, we get pq plus qr plus rp. Now, note that p, q, r are roots of a cubic equation. So we know that the relation between roots and coefficient gives us this terms: a1 by a0 equal to minus p plus q plus r, a2 by a0 equal to pq plus qr plus pr, and a3 by a0 equal to minus pqr. So let the cubic equation having roots p plus q plus r is a0 y cube plus a1 y square plus a2 y plus a3 equal to 0. So dividing this equation by a0, we get y cube plus a1 by a0 y square plus a2 by a0 y plus a3 by a0. So putting the values of a1 by a0, a2 by a0, and a3 by a0, we get this equation. Now we need to observe this equation and find the suitable value of y to make this equation 0. And here it is y equal to 1, that is suitable to make this equation 0. So after putting the values and solving this equation, we can get the values of p, q, and r. Now, since we have the values of p, q, and r, we can have the values of root p, root q, and root r. Now, as we know, since root p, q, r is minus 2, so the following combinations are possible. When multiplying these three values of root p, root q, and root r, we can get minus 2. So x equal to root p plus root q plus root r. So these values are then added, and then we get the values, 4 values, that are 1 plus I root 2, 1 minus I root 2, minus 1 plus root 6, minus 1 minus root 6.